Hey class, Absolute 5 here, and today we're going to talk about exponents. Now, I may have covered exponents before in another video, but this is like the real in-depth guide of how to do exponents. We're going to cover a lot of topics. This is going to be a nice 4 or 5 part video of exponents. So as we know, what are exponents? It's where you have a letter here, and the n on top is the exponent and the a at the bottom is the base. That's just in general terms. I could take any number, so let's just say a is going to be 3, and I say the top number is, let's say, 4. It tells you, the exponent tells you to write the base 4 times. That's just the example here. So that's why, in general, when you were to write this, this is a to the 1, times a to the second, times a to the third, and times ... a to the n, whatever. The point is, in general, it's just telling you in general that no matter what exponent you have, it has to look this way for it to be as exponent. So this example here with 3 to the 4th is a very good example of what an exponent is. So I'm pretty sure you know what that is. By the way, answer to that, 81. So let's continue. So now a question could be, what happens when you have two exponents? So first off, can you multiply two exponents with different bases? And the answer to that question is no. So for example, if I have 2 to the 3rd times 4 to the 6th, this is a big no. You can't multiply through, so you can't get like 8 to the 18th. That's a big no. You cannot do that. It just doesn't work. Two different bases, it just does not work. So to answer that question is no. You cannot multiply two exponents with different bases. They have to be the same bases. So that leads me to this topic of the product rule. Now, what is the product rule? And now for each of these rules are for exponents only. So the product rule is where you take two bases that are the same base, but their exponents are different. Now, we can do this the long way, which I'll show you. I'm going to write out each one. So I have to write out 5 4 times, multiplied by 5 3 times. And now I just simply count how many 5s are there, and I'm left with 5 to the 7. Or to make things much, much easier, I take 5 to the 4 times 5 to the 3. I write one base, 4 plus 3, and I just get this as 5 to the 7th power. Now, choose whichever way you want to learn how to do it. That's on you. But I'd recommend that method more because it's much easier to do it. I only show the first method just to showcase if you like doing things the long way, you get to see everything the long way. All right, so in general, how do we do this? So in general, and this is for product rule, if m and n are positive integers, wow, let me just give myself more space to write integers. And a is a real number, then a to the m times a to the n means a to the m plus n. So what this is saying is that if you have two bases with the same base and they have different exponents and they're being multiplied, you simply multiply you keep the base and you add the exponents. That's what I mean to say. You keep the base and you add the exponents under the operation of multiplication. There we go. So say, for example, let's have another example. 3 to the 5th times 3 to the 7th. Well, using this rule, it's going to be 3 to the 5 plus 7, which is going to be 3 to the 12th, which is a very, very large number, which I'm not going to calculate. That's a big number for me to do that right here. Let's do some more examples. So let's say if I had 4 to the 2nd times 4 to the 5th would simply be 4 to the 2 plus 5, which would be 4 to the 7th. So I feel like you're getting the gist of this rhythm. Good. Now let's change up the rhythm just a little bit. What happens on this example? 2x to the 2nd times negative 3x to the 5th. Now, I know what you're saying. I just threw in that variable there and now you're kind of going crazy. No, don't do that. Let's do the numbers first and then the exponents, okay? So the numbers are 2 times negative 3, or better yet, let's do the sign first. Positive times negative, negative. 2 times 3, 6. Good, we got that out of the way. Next, we do the exponents. So now we have this as, if you just look at the exponents, this would be x to the 2nd times x to the 5th, which would just be x to the 2nd plus x to the 5th, would simply be x to the 7th as your answer. Granted, again, if you're really good at this, you just simply look at it and just say, okay, I know what this is. It's going to be this answer. Let's do another one. 6x to the 3rd times negative 2x to the 9th. So again, you do the numbers first, but first importantly, do the sign. So negative times, well, positive times negative is going to be negative. 6 times 2 is 12. And 3 plus 9, 12. And you're done. So the best way to go about this is, again, is practice, 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 and to always be adaptive of the situation of what's going to occur. So I'll give you 2 problems this time, since I gave you 2 different topics. I'll give you y to the 3rd times y to just y. And the other problem, so that's problem 1. Prob 1, and this will be problem 2. And let's say I gave you 9x to the 3rd. Let's make it negative 9x to the 3rd. This is a negative times 4x to the 6. And that's also negative, by the way. So those are your 2 problems for you to do for homework, whatever. These are optional, these are not necessary. So if you have your answers, be sure to leave them down in the comments down below. And that's the lesson for you guys. So I hope you enjoyed the video. Be sure to like, share, and subscribe to this channel. Mash that bell button for more content, and I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate. Whoop.